Okay, let's look at the numerical number 3. A body is moving in a straight line and its displacement at various instances of time is given in the following table. Now the question is, first thing is to plot the displacement time graph. So let's try to figure out what is the displacement time graph. For that, let me just draw the x-axis and the y-axis. So let's say this is our y-axis and this is our x-axis. So let me just label it. This is our x-axis and this is our y-axis. We'll take the time on our x-axis and we'll take the displacement on our y-axis. Now, if you look at the time is going from 0 to 7. So we don't need to take any particular scale. We can just go from 0 to 7. So let's just mark 0 second, 1 second, 2 second, 3 second, 4 second, 5 second, 6 second, and 7 second. So this is 1, 2, 3, 4, 5, 6, and 7. Now again, the time is given in seconds. Now if you look at the displacement goes all the way from 2 to 24. So we can take 1 centimeter equals to 3 meters. So let's say this is 3 meters. This is 6 meters. This is 9. This is 12. Oh, I guess that will be a lot. We need to make it a bigger units. So let's remove this. Let's say we take the units as 6 meters. So 6, 12, 18, 24. This is my scale for the displacement. So let's try to plot the graph at 0 seconds. The displacement is 2 meters. So the 0 seconds, time is 0 seconds, displacement, let's say displacement is over here 2 seconds. So this is our point 1. After 1 second, displacement becomes 6 meters. So after 1 second, my displacement becomes 6 meters. So this is our second point. After 2 seconds, 12 meters. So after 2 seconds, this is my 12 meters. After 3 seconds, 12 meters. So after 3 seconds, also 12 meters. So somewhere over here. After 4 seconds, still 12 meters. So after 4 seconds, still 12 meters. After 5 seconds, 18. So this is 18. And this is 5. So let's say over here. After 6 seconds, 22. So 18 and 24. So 22 will be somewhere in the middle over here. So after 6 seconds, well, let's say this is the next point. And after 7 seconds, 24. So this is after 7 seconds. These are all my points. Now, if I draw a line to join all these points, this will give me the graph starting from here. I'm going to draw a straight line because graphs are normally a straight line like this. Of course, my graph is not exactly up to scale, so I might be missing a few points here and there. But if you take a proper scale in a graph paper, your graph will be a proper straight line. So first part is done. Now let's look at the second part, which is find the total distance traveled in the time interval 1 to 5 seconds. So we have to find what is the displacement when time equals to 1 to 5 seconds. Now from here, we already know from at 1 second, the displacement was at 1 second, the displacement was 6 meters. And at 5 seconds, the displacement is 18 meters. Now this is the final position and this is the start position. So if you subtract final minus start, which is basically 18 minus 6, that will be 12 meters. So the displacement in seconds 1 to 5 is equal to 12 meters. Now, second thing is we have to find what is the average velocity in time interval 1 to 5. So average velocity equals to total displacement divided by total time. Now in this case, our total displacement is 12 meters and the total time is from 5 to 1 second or from 1 to 5 seconds. So 5 minus 1, the time taken is 4 seconds. So 12 divided by 4, which is equal to 3 meters per second. And 3 meters per second is the average velocity of this